Algebra 1, Lesson 11, and we're going to do Lesson 12. The focus on this lesson is multiplying and dividing real numbers. So that's our goal, and then later with Lesson 12, we're also going to look at some of our properties that we have with our operations, some of those common ones. So first of all, some vocab that you will need to know. Reciprocal is a very common word. That means that we are flipping a fraction, so the numerator is the denominator and the denominator is the numerator. Basically saying if we have something like 3, well, its reciprocal is 1 over 3, because we can put this 3 over 1, flip it, so it's 1 over 3. Or if we have 2/3, its reciprocal is 3 over 2. Big thing to know here with reciprocals is when we take the original number times its reciprocal, it will always give us 1. And that's one of our properties that we'll look at in a little bit. So let's look at some of the things that are going on in this lesson. Alright, so some of the properties that we need to be familiar with are things like multiplication property of -1. Well, whenever we multiply a real number with -1, we will get the opposite of the number. So 9 times -1 is 9. -1 times -9 is +9. And the multiplication property of 0. Every number multiplied by 0 is 0. Regardless of what number, we multiply it by 0 and the result will be 0. Lastly, just like I was talking about with those reciprocals, when we take a real number, except for 0, the inverse is the number flipped on itself, so the reciprocal is what we're talking about. So if we take 3 times 1/3, we will get 1. Okay, so a number and its reciprocal multiplied will always be 1. Some of these will have different names, like the multiplication property of 0, we will call zero product property sometimes. And inverse property of multiplication sometimes will be the multiplicative inverse. You will see those names every once in a while. The other thing to remember is when we are multiplying positive and negative numbers. So a positive times a negative is a negative. Negative times a positive is a negative. So whenever you have different signs multiplied together, we get a negative. But if we have two signs that are the same, either two positives, two negatives, we will get a positive. The exact same rules are true of division. So different signs give us a negative. Same signs give us a positive. And the question here is, well, what happens when you have 3 of something? So maybe a negative times a negative times a negative. Well, just like with order of operations, we start with the first 2. And these 2, since they're the same sign, will give us a positive. And then we multiply by that negative, and since we have different signs, we end up getting a negative. Okay, so just go 2 at a time, working through it, just like with order of operations. Let's try some of these out. So if we have -5 times 3 times -2, let's start with the -5 times 3. Different signs, so we get a negative result of 15. We multiply those together multiply that with -2, and since they're the same sign, we get a positive 30. Okay, and the next one here, 2 negatives make a positive 8. We multiply by -7. Different signs give me a negative result of 56. Now let's look at -3 to the 4th. Well, that means I have -3 times -3 times -3 and another -3. Well, all of those, since we have 4 negatives, each pair will come out positive, so we end up with a positive result of 81. But the difference here, when we look at this next one, right here, of -3 to the 4th, this means that I'm going to take that negative, and technically it's -1 times a 3 times 3 times 3 times 3. Which means that we get 81 with those 3's, and then we have to make it negative because of that multiplying by -1. Remember, we must do exponents before we multiply. Okay, so here's the difference. When you see parentheses around an entire number, like -7, and we are going to square it, well, that means that -7 times -7 gives me 49. But let's say, kind of like this one right here, we have a -7 squared. Well, there are no parentheses around the entire -7, so only 7 is being squared. So we have a -49. All that to say, parentheses are extremely important when we're talking about negatives, talking about exponents. Okay, so if there is a parenthesis around the entire number, that entire number gets squared. Whereas if there are no parentheses around that number, like -7 squared right here, we have to do the 7 squared first and then make it the opposite, make it negative. Okay, let's look at our -3 to the third. Well, that is -3, -3, and -3. Well, we have two negatives make a +9 times a -3. Different signs give us a -27. Finally, let's write this as its fraction form, 2/3 and divided by -4/5. Well, what we know about dividing fractions is that we take the first one and repeat it, we copy it, we multiply, and we use the reciprocal of the next one, so 5/-4. Doesn't actually matter if you put that negative on the 5 or the 4, just that one of them is negative. And we see that we get a result of a positive, because there are two negatives, a positive 5/6 when you reduce. Okay, big concept here is the fact that parentheses matter. Okay, so let's look at these two. The deepest known cave in the world is an elevation of -2140 meters. It takes 8 days to travel to the bottom. What's the average number of meters a caver would need to travel each day? Well, we are dividing here, and we have a -2140 divided by 8. Well, we already know, since we have a negative and a positive, different signs, we are going to get a negative result. And when you divide that, I believe you get 267.5. Now this next one. During a cold spell in January, Homer, Alaska recorded a low temp of -24 degrees. The city of Bethel, Alaska recorded a low temp twice as cold. What was Bethel's temperature? Well, we have two different signs here. We're going to multiply and get -48 degrees Fahrenheit. That's cold. That's very cold. So just to make sure that you understand the difference between some of these, let's just look at if this is going to be negative or positive. Well, two different signs, we're going to get negative. Same signs, we get positive. If we have -4 to the third, that's -4 times -4 times -4. Well, with 3 negatives multiplied, we get a negative result. -8 to the fourth, since we have -8 4 times, we end up getting a positive result. It's going to be positive for sure. Now this one, just like what we were talking about, we have to take -1 times 5 times 5 times 5 times 5. We are not using that exponent for the entire -5. It's just for 5. So we end up getting a negative result. -5 to the fourth is going to be negative. Okay, for this one, we are going to get a negative divided by a negative, which means we're going to get a positive. Different signs we get negative. And these, remember, copy, dot, flip, but the important thing is negative divided by a negative, we get a positive result. Okay, let's look at lesson 12 very quickly. Okay, So, sorry about this, I should have cleared this before. Let me just do a little bit of deleting. So you can start to see what the goal is here. Okay, so when we look at these, we can kind of see, all right, these are showing us either associative or commutative. Well, remember that associative is when we don't change the order, but we do change the grouping, which we have in these cases for sure, okay? And we have it combined with commutative here. And remember, commutative is when we change the order. Now this is the one that gets a lot of students confused, mainly because it looks like it's associative because we're talking about parentheses, but as you notice, the grouping 8 plus 2 doesn't change. Only where this positive 3 is changes. Let's look at these ones. Okay, these are examples of some of our identities. Okay, additive inverse, we are talking about if we have an a number, plus its opposite, negative a, that result will always be 0. Whereas with additive identity, we are looking for a number plus something that will always keep its identity of a. Well, that would be 0. Anything plus 0 stays the same. Multiplicative inverse, we are talking about if we have a b times its reciprocal, so 1 over b, we end up getting 1, just like we saw just a few minutes ago. And multiplicative identity, we are looking for a number times something will give me that original number, keep its identity, and that of course is 1. So we can see some number examples with these. You can have a number times its inverse gives me 1. A number plus its opposite gives me 0. A number times 1 gives me its identity. And 3/4 plus nothing equals the original 3/4. Okay, so let me go step by step. This asks, take this expression, simplify it, justify each step. Well, the big thing here is I know that I'm going to need to get this 16 and this 4 together so that I can add them, okay? Because 16 and 4 are like terms, 3x is not a like term. So first we write down what we are given. Remember, doing this type of thing is extremely important as you get into higher and higher math. It starts in geometry, but it continues for a long time so that we can prove different theorems given the different properties that we have. So first, I'm going to move this 4 next to the 16, okay, or the 16 next to 4. It doesn't matter which way. And that would be using the commutative property of addition. So I write down a step, I write down its justification. Okay, I put parentheses around the 16 and the 4 to remind myself that I need to do that first. I should do that first. So that's the associative property, putting different groupings. And lastly, we add. That is our final step. Since we're not using a specific property, we are showing what we did to get my final result. Similarly, let's look at this one. Okay, we are given 25 times y times 1/25. Well, I want to get that 25 and 1/25 together, so I use the commutative property. I multiply. Remember this, we can say even being able to multiply to say it's -1 is using our multiplicative inverse. Okay. And then if we're multiplying a number times 1, well, that's using the identity property of multiplication, and that is our final step. So taking something and justifying our results as we go through. Okay. All right, let's talk about this one. Okay, and it'll be, I believe, yeah, it'll be our last one. Envelopes, pens, and correction tape can be purchased at an office supply store.
If I could have your attention, please.
Sorry, there's an announcement.
A white Toyota Corolla, license plate 397JRY, that is blocking one of our neighbor's driveways. We need you to move that car, please. It's a license plate 397JRY, a white Corolla. You
All
will
right.
get ticketed if the neighbor calls.
This,
so please move your car.
all right, the announcement is over. So if we have envelopes, pens, and correction tape for 285, 535, and 215, find the total cost and justify your steps. Well, we take what we are given and we know that we need to add them together. Well, to make our lives easier, we know that this 215 and 285 is, when we add those up, we're going to get a nice round number that's going to make our lives really easy. So we're going to use the commutative property to get those together. We use the associative property to remind ourselves that we should do that first. And finally, we add within the parentheses and get a final answer of 1035. So if you want to try these two examples out, go for it. Remember, justify every single step. Move this 4 to get it to somewhere where it needs to be. Move the 3 so that you can use the multiplicative inverse. Well, I hope this was helpful for studying and for your homework.